Dr. Simon Roth from Robert Bosch. He's a computer scientist and software architect with over a decade of experience building complex automotive products, primarily focusing on software-defined vehicles and software-defined vehicle architecture. So we met with Simon through work on SysML v2, and in particular, Bosch showed a lot of great initiative and work contributing test cases for SysML v2 conformance effort, and and the whole community should be thankful for Simon and the team at Bosch who started the way towards SysML v2 conformance, and it's still the case that Seaside is the only tool that passed all the conformance tests available. So, if you use any other tool for any reason, please encourage your tool vendor to do the same. So, welcome.
Okay. Okay, thank you, Justus, for the nice introduction. So, hello to you all. My name is Simon. As said, so I'm working meanwhile since more than 50 years, I realized, in the automotive industry. And so, as you might have heard, there's a lot of change ongoing also in the software for the software development in the automotive industry. There is one big change in paradigm, what we call the so-called SDV, the software-defined vehicle. So this means today, the automotive systems mostly shaped by drive experience. So how fast is the car, how many horses you have under the hood, and so on, and or how big the tires and so on. But we see a very big change here over the last years, or the last decade, that the car is getting more and more defined by other functions. So how good is the navigation? That's not just how big the displays are and so on. Also, how good would a manufacturer be capable of bringing new functions into a car while it is already in series, meanwhile, maybe since 2 years, 5 years, and so on. And that's very, very big change, these integrations with updates, with cloud functionality, what is running outside of the car. And all of that needs, of course, to be safe. So, and therefore we think about, or we're facing here really the point how we can go on, how we can make all of this far faster compared to the past. So we already heard, I guess it was from Mark, saying that BYD has an innovation period of 1.5 years for a complete car. When we're just thinking back some years, 3 or 4 years, we had 4 to 5 years from the initial sourcing of some automotive components for the whole development until it is series ready for production. And now we need to decrease even more to 1.5 years, or possibly even less for some products. And that brings so many challenges for us for the whole industry here, where we really need to cope with. And we were looking really appreciating to SysML v2 in the hope that it will help us, and I guess it will. But on the other hand, of course, where it's light, there's also shadow. And so as we started already in some smaller initiatives already in 2022, some elaborations and small-scale evaluations while the language development was still ongoing, or let's say still quite early phases. So we collected here a lot of feedback and a lot of interesting observations from the first steps to engineering everyday work here. What we far not achieved, that's also clear, but where we are on the way to, and I would like to share a bit about that with you. So therefore, we talk here about what are the personal observations, or how do people behave in that environment. So here we see the people are very, very open and interested and willing to adopt to SysML v2. What is in a usually quite conservatively acting industry is a really, really good sign. And that is also, of course, a sign of that the people really understood that they need to change things and that we need to develop further, but also, of course, come in or is partly also driven by the pains we had in the past with SysML v1 or even working without MBSI. And so here, really interesting to see that especially people on a system engineering level, so this means classical traditional system engineers who never were able or were never forced to or never had the motivation to write code, let's say like that, started using and adopting to the textual notation and really like to use it and love to smoothly switch between the notations where they have in their individual strengths. And that is really a good thing, good sign here, what we see with SysML v2, how this can really bring us further here. Also, really good thing is the other or what people really perceive here really well are the integration possibilities. For example, for simulation or also for Dox's code, and so we made here a lot of small-scale POCs over the last 2 to 3 years here, where we started with that to assess what is possible, to check also how the people perceive it, how the people want to work with the stuff, to bring here the whole ecosystem further. Also, we see here that the people really appreciate the individual improvements that were made in the language compared to SysML v1. So this means especially, or just to mention two of that here, just to overcome these quite limited and very special integrations of the static and the dynamic view that were there in SysML v1. That is really highly appreciated, how this is becoming more and more usable or become far better usable in SysML v2. Also important to mention the diagramming facilities, which was also something quite static, in SysML v1, the BDDs, the IBDs, and so on. Some quite static or some quite clearly defined content per diagram type. Meanwhile, in SysML v2, this became far more open with this extremely flexible view and view definition concepts here. And this is something that will really help us and bring us further. Of course, especially also with the integration then of proper tooling for exploration, like with Tom Sawyer. And so this will really add something really beneficial. What we also seen, of course, the light there is shadow. So the really steep learning curve with SysML v2. It's quite hard to get started in the beginning, and especially when or also when you want to roll it out later to the normal users, not just to some individual power users in the beginning. We really need to have proper guidance for the people and really need to help them to get started and doing the right things in order not to frustrate them and not to lose them on the way. And therefore, that all of this can happen, we really need to grow a culture to more openness and change, especially in the methods and the processes with what we work and how we work, and not just focus on the product here. Looking a bit more on the method side, our guiding question here to ourselves when we started working here with SysML v2 was, how can we bring MBSE to the next decade? So, because in the past it was perceived, and not just perceived, I considered more as a fact. It was too complicated in many cases, or for too many kinds of product. It was too expensive and too slow. And so therefore some questions, some aspects that really attracted us here at SysML v2 are the questions: how can we work model centric versus file centric? So how can we bring in more software centric or software coming from software culture driven styles of working, like Git flow and all of these branching concepts and exchange concepts, and so on, getting rid of the classical one single monolithic platform which hosts a single model where all of the people and all of the users need to access every time the same model, and locking themselves and having no possibilities to experiment and to drive things further, because all is in the same database for all of the time on the same branch. And so we clearly for all of the methods we are now shaping at the moment, we need to, or we realize that we need to establish an architecture to change. This means not only for the product, where it's already there more or less and understood since year that it's needed, but also for the methods. And I guess this is also something what Michael said just some talks ago here. It's really the key is that we also be capable to develop ourselves, our working styles, our methods further while we are still productive and developing productively for the next generation or not, or for the next iteration of our products. And so therefore we've seen that we also with our methods and complete tool stacks and everything what's relevant here, we need to experiment, find ways that find promising ways, prototype them, and then scale them to the next steps and really bring them to production. Therefore, that this can work, we need to do, or we need to create instant feedback with appropriate methods. So there are things like that we learned already in the software environment in the last decades, also from DevOps style and from the SecDevOps and so on. And all of that, of course, requires revisiting frequently, and especially that we dare to evolve. That is something that really goes back to the point of the culture here, that we're not getting stuck somewhere on the way, getting stuck with something that someone got developed. We need to go further and bring things further and further all of the time while we are working on it. So, and the tool perspective here, we see also plenty of new tools coming up that hopefully help us here. So we have here a lot of new or some new open source projects, some bit more classically designed tools, and all of them having their values, having their users, and having the point in time where they are right. And also we see here that it still needs some more and more. I need to hurry up a little bit, I realize. So really important, and that is also what Josa said in the introduction here, that all of this can really work out. We need to have conformance. So this means the tools need to be capable for integration. They need to interchange data. And why do we need it? Quite simple, because one single tool cannot fulfill all of the promises and really cope with what SysML v2 offers to all of us and what we need in the various industries here, not just in the automotive industry in the future. And so we need to come clearly here from single individual tools, which are locked more or less into proprietary platforms. We need to move on and need to shift here to open model-based ecosystem, where we're having all of the capabilities, where we can work and integrate, where we can innovate, federate, and automate, such that we can evolve all of our styles or ways of working, and also how we integrate and how we work with our models in the future. And so there, I really appreciate what the guys from SenseMetry have done with CSAND, with Seaside, and all of the other tools coming here, which really are completely designed to be very open, integrate with all of the other stuff, allowing us to integrate here also the great this large proprietary authoring tools with their strong capabilities in certain aspects. But then also allowing us to switch in the development to textual notation, going back and forth, integrate with docs as code or model as code, allowing to link from the outside, having some safety tools, having software integration, simulation, optimization, also the great interesting AI agents that we've seen here already today. And all of this really needs that we going on, that we shape the culture and the ecosystem together, so that SysML v2 will become a great success for all of us. Thanks a lot. So I'm leaving a bit of time for questions, hopefully.
Thanks so much, Simon. So many lessons already learned. And one quick question from the audience, from Sriram Krishnan from Istari Digital. a US-based digital engineering company and startup that's quite well known. And the question is, what have SysML v1 users felt about code-first approach in SysML v2? What is the feedback from users who want block diagrams and visuals?
Yeah, so I just briefly touched this point. So we also made here some experience or started working quite in the beginning with some core system guys who never wrote code, never worked with code files or docs as code or something like that. They very classically always worked with SysML v1 models since 10 years or even longer. And so in the beginning, they just, so the tools were not that mature as they are today when looking back 1 year. And so they had a little bit of nudge in the direction by the maturity of the tools to start and to work more with the textual notation. And the very first feedbacks about the first days about, ooh, that's hard. And it's completely against to all of how we worked and so, and we don't believe in the success of that. But luckily, those people of whom we worked here, they were really very open and motivated enough to give it a try. And several of, or all of them came back after some more days and said, "Oh, wow, now we that's far more powerful and really interesting to work in that way with the textual notation, and and we really want to do that." And now when we're doing did some further experience with the later versions of the tools here, for example, also with Cameo, and so the people really so those ones who in the beginning got the push to work with textual notation, there we really seen how smoothly they can work with both notations, the graphical and the textual notation, and switch interactively in mid of the working flow or in the modeling flow to that aspect or to that notation that brings for that certain aspect the most benefits for them. So what is further needed so is of course something like as you have in users in science symmetry with the Tom Sawyer integration. That's great for exploration, and especially that helps that we don't need to spend too much time from the beginning in diagramming. So we can really focus more on the model content, explore it, but also, of course, we need some automated diagram rendering out of textual notation or out of textual definitions, as it is basically foreseen a bit in the language, but this needs some further improvement from the standard side, in my opinion, for the next year, so for the next version of the standard.
So we are working on it, and many improvements to the visualization are coming also soon, even more to the Seaside modular. So the next speaker, thanks again, Simon.